Matter in its three phases? Solid, liquid, and gas? That can't be right.
Now, I know we all heard about the three phases of matter in first grade: the solid, the liquid, and the gas. And then maybe if you had a cool teacher in 7th grade, you learned about the fourth state of matter, plasma. But there's a fifth, the Bose-Einstein Condensate. Let's get into that.
Back in the age of flappers and prohibition on the other side of the world in India, Satyendranath Bose sent a paper to the one and only Albert Einstein discussing the quantum statistics of photons, a fancy way of saying how certain groups of photons behave. Einstein then took this and expanded on it to create the theory of Bose-Einstein Condensate.
Now, how exactly do we get a Bose-Einstein Condensate? You know what? One second. I'm kind of hungry. Now, how you get some Bose-Einstein Condensate is you take some bosons, such as certain types of rubidium or hydrogen, and put them in a container and get them cold enough that they can reach 0 Kelvin, which is also negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. Sadly, our freezers don't get this cold. So, how do we make a Bose-Einstein Condensate? This was wondered for a long time. Up until recently at MIT in Boulder, they were able to create a Bose-Einstein Condensate using a combination of two different types of cooling techniques. One, where they used specially designed lasers to cool down the particles, and another called evaporation cooling, where they allow for the high energy particles to flow out, creating a much lower energy material left at the base. Kind of like how when you have a cup of tea, you allow for the steam to rise out, creating a much cooler cup of tea. Now I know what we've all been really wondering. What exactly is a Bose-Einstein Condensate? Here, wait, 1 second. Let me get dressed.
All of these various different versions of me are like atoms. Then all of these atoms start behaving like waves. But then they start getting longer and rolling into each other, start moving together to make like a clump. And suddenly this atom can't tell if it's in this area or this area of the mass or where it is, and the mass starts acting like one big wave itself. This mass is what we like to call the Bose-Einstein Condensate.
Oh no, I'm gonna be late. Okay guys, I'll see you later. Bye!